Hey, welcome to Scope Quick Start video. Scope is an open source tool for the running real-time interactive AI pipelines and models. It currently ships with several different real-time AI video models, supports LoRa style adapters, visual conditioning with Waze, and we have an entire plugin system for extending it with new capabilities, plus multiple input modes including webcam, video files, and even Spout for interrupt with other tools. In this video, I'll walk you through features that make Scope such a creative tool. The easiest way to get started on Windows is by running our desktop app. You can head to Daydream Scope releases pages on GitHub, click on tags, find the latest release, and just run the exe like you would run any other Windows file. You can then easily launch Scope from your start menu. That's it, no terminal, no dependencies to install manually, it just works on your machine. This is pretty much how the Windows app looks when running on my machine. But running a Windows app is not the only way you can run Scope, right? So if you prefer command line or want a full control over the setup, you can install from source. You will need an NVIDIA GPU with at least 24 gigs of VRAM, CUDA 12.8 or higher drivers, the UV Python package manager, and Node.js installed. So the first step is to clone the repo, and once you're done, you should have something like this on your local machine. Now, go with UV run build to build all the dependencies in the system on its side. Now this has run pretty fast on my machine because I already have it pre-built, but when you're doing it for the first time, allow for some time. And then next step is to UV run Daydream Scope. And just like that, you will have Scope running. If I now click here and open it, you can see my Scope completely open and running for me. If you don't have a local GPU, you can run Scope on Rumpad. We provide pre-configured template. You just need to click the deploy link from our docs, pick a GPU, and make sure that it has at least 24 gigs of VRAM. Set your Hugging Face token as an environmental variable. That is also explained in our docs for reliable video streaming in cloud environments, and deploy. And you can easily access your instance at the port 8000. As I said, there is a full video explaining and showcasing how this is done in detail, so make sure that you check it out. We are also working on Daydream Cloud for one-click remote inference with no setup at all. So even if you don't want to use Rumpad, you will still be able to use Scope locally with the remote inference happening in the cloud with a very simple and unified user experience. Now, I'll continue this tutorial by running Scope on my local machine. So when you first open Scope, you will see a clean interface with long live pipeline pre-selected. There is already a prompt prepared for you that you have visible here. It's a detailed scene of a 3D animated panda walking through a park on a spring day. This is actually designed to get you to your first generation as quickly as possible without having to think too much about different settings. So all you need to do is hit the play button, wait for a model to download. This might take a while depending on the size and the kind of model that you're running, and you should see the generation running in real time. Let's give it a moment while our models are getting downloaded. All right, and I have my video running. Notice that, the exact speed and the number of frames per second that you will get strongly depends on your hardware, but you'll notice that there is no render queue, there is no progress bar batching. All of this is generated frame by frame live in real time. Now, keep in mind that this default Panda example uses text to video mode, right? So basically what we did, we entered the prompt here. And this means that, prompt drives everything. But Scope actually supports multiple input modes. You can change them by going to Input Mode dropdown, and you can select either a text that has been shown before, or you can go by video. So when switching to video mode, you can use even your web camera as an input. The model will then transform your camera feed into real time based on the prompt. You can also load the existing video file, the case that I have here, or you can even use Spout. I'll talk about Spout and integrating with other tools a little bit later, but this basically means that you can receive video from other applications and feed it into Scope for different transformations. Okay, now experiment a little bit while in the video mode, right? So now I have my cat as an input here, and still my prompt says a panda walks along a path towards the camera. Let's see what happens when I hit play. Nice, it tried to combine panda with this cat video, but you're not limited by, setting up the prompt for the first time. I can actually go and say, instead of panda, let's go for a fish. And you can see that, transitions and changes are happening in real time. I pretty much have unlimited opportunities for me to create them. So I'm not limited by, traditional batch processing of videos and having to wait for them to generate or regenerate in time. Scope itself ships with multiple pipelines. And let me walk you through a couple of them. So we already seen the Long Live. Long Live has been created by NVIDIA and collaborators. It excels at actually smooth prompt transitions and pretty long time extended generations. It's what we've used for the default Panda mode demo, but also for this video source input. In addition to that, we have our Stream Diffusion V2. It's the original real-time streaming pipeline from the Stream Diffusion team, built on the WAN 2.1 1.3b model. It is a great all-arounder with a good balance of speed and quality. Then there is Kria Real-Time. This one is a heavyweight. It is based on the larger WAN 2.1 14 billion parameter models, meaning that it will come with a significantly higher output quality, but it also requires at least 32 gigs of VRAM. If you have an RTX 5090 or similar, that one is, this one is the one to try, but it will benefit from having even better or higher GPUs. Then there is reward forcing. This one uses a technique called reward distribution matching, improving the output quality on the smaller 1.3B model. And there is also MemFlow, which has a unique memory bank mechanism that improves consistency over longer generations. So output should stay coherent even over the longer time horizons. There's a bunch of others, but these are the main model ones that we are showcasing. Okay, let's talk about LoRa's. What I have here is a pretty nice and simple prompt that basically shows a small brown puppy with floppy ears sitting on a grassy hill, tilting its head curiously in a photorealistic style, right? So this is something that model generated on its own without me doing any changes to its visual appearance or style. Now let's try something else. I am still using the same pipeline, so it's Kria Real-Time Video, but this time I'm going to use and apply a LoRa adapter. I'm going to click on the plus sign. I will select my LoRa file, which is Pixar 10 epochs, and I will give it another prompt. So this prompt is essentially the same as the previous one when we had this photorealistic puppy, with the only difference being this Pixar style keyword, or basically a trigger word that should give me a different vibe altogether. So let's hit play and see what happens. Okay, now look at the difference, right? The same prompt, same pipeline, but this time with Pixel LoRa enabled. The entire generation shifts to a 3D animated movie aesthetic. And you can load multiple LoRa's, so you're not limited just to one of them. And you can adjust the scale of each one to dial in exactly the look you want. LoRa's are generally simple to use. What you need to do is download a .save tensors file from Hugging Face or Civit AI, drop it in your LoRa folder, and it shows up in Scope automatically. There is a detailed LoRa guide in the docs that walks you through everything, including which LoRa's work with which pipeline. Scope also does support WAIS, and WAIS stands for Video All-in-One Creation and Editing. This basically lets you guide your generations by providing them, for example, a reference image that will let model maintain the character or style throughout the generation. Or you can even use a control video like a depth matte or pose estimation to drive the structure and motion of the output. WAIS can be enabled and disabled in this section here. It is still experimental in our implementation, but it is already producing really impressive results. So I would encourage you to check out the WAIS guide in our docs to get started as well. And one thing that I mentioned earlier was spout receiver. Scope does not live in an isolation, right? So if you're running the Windows app, Scope supports Spout, meaning that real-time video sharing is enabled between Scope and different apps that you might be running on your machine, right? This means that you can pipe Scope's output straight into Touch Designer, Unity, Blender, OBS without any third-party screen capture. But Scope goes beyond the spout receiver that I've just showed you. So Scope also has a plugin system that lets anyone extend it with new pipelines or capabilities. So for example, you can install plugins from the Git repos or PyPI or even local directories. We see people building NDI support through plugins, for example. And the first plugin that we ever implemented was this Scope Overworld plugin that enables a Scope Overworld pipeline that is visible here. So everything I showed today is covered in detail in our documentation. That means installation, all 5 pipelines, LoRa's, Waze, the API reference, and the plugin development guide. As mentioned many times in this video, Scope is fully open source, right? So you can contribute on GitHub, you can join our Discord for help and to connect with other creators. And please be sure to check out Community Hub at app.daydream.live to see what others are building and also collaborate and share with them. Thank you for watching, and now go and make something cool with Scope.